the SSS, side-side-side, Similarity Criterion. Hello everyone. Before we dive into today's new topic, let's take a quick moment to reflect on what we have already learned. In our previous lessons, we explored how the equality of angles can be used to prove that two triangles are similar. However, geometry doesn't always give us all the angles up front. It is also possible to determine if two triangles are similar by looking only at the lengths of their sides. This brings us to our main focus for today, the SSS, or side-side-side Similarity Criterion. We are going to learn how to use side lengths to establish similarity without needing to measure a single angle. 1. Understanding the concept. The most important thing to remember about the SSS Similarity Criterion is that it focuses on proportionality, not equality. I want you to really distinguish this from what we learned about congruency. In congruency, we are looking for sides that are exactly the same length. However, for similarity, we don't need the sides to be identical. We just need the ratio of the corresponding sides to remain constant. Think of it like zooming in or out on a photo. The size changes, but the proportions stay the same. This brings us to Theorem 6.4. This theorem tells us that if the sides of one triangle are proportional to the sides of another, then a very important thing happens. Their corresponding angles automatically become equal, which means the two triangles are officially similar. Let's look at this mathematically. Suppose we have two triangles, triangle ABC and triangle DEF. We can prove they are similar using the SSS criterion if the ratio of side AB to side D is equal to the ratio of side BC to side EF, which is also equal to the ratio of side CA to side FD. If you can successfully prove that these three fractions are all equal to the same value, then the math does the rest of the work for you. It automatically follows that angle A equals angle D, angle B equals angle E, and angle C equals angle F. Once those angles match, we can formally state that triangle ABC is similar to triangle DEF. Now that we've introduced the topic, let's dive deeper into the core concept. In the next slide, I'll show you a clear, step-by-step process you can use to perform these calculations yourself. 2 step-by-step process to prove SSS similarity. Now that we understand the theory behind the SSS Similarity Criterion from our previous slide, let's move on to the practical application. I want to show you a clear, logical, 4-step process you can use every single time you are faced with a problem like this. First, we begin with step 1, identifying the corresponding sides. When you are looking at two different triangles, you shouldn't just pick sides at random. To be as accurate as possible, I recommend a very reliable method. Pair the shortest side of the first triangle with the shortest side of the second triangle. Then, pair the medium-sized side of the first with the medium-sized side of the second, and finally, pair the longest side of the first with the longest side of the second. This ensures you are comparing the correct parts of each shape. Once you have your pairs, we move to step 2, calculating the ratios. Here, you will write out the relationship between these pairs as fractions. You'll create 3 distinct ratios. Your first ratio will be the shortest side of triangle 1 divided by the shortest side of triangle 2. Your second ratio will be the medium side of triangle 1 divided by the medium side of triangle 2. And your third ratio will be the longest side of triangle 1 divided by the longest side of triangle 2. This leads us directly into step 3, comparing the ratios. At this stage, you need to simplify each of those 3 fractions. Your goal is to see if they all reduce to the exact same numerical value. If they do, that value is what we call the scale factor, and it proves that the sides are proportional. Finally, we reach step 4, concluding similarity. If, and only if all 3 of your simplified ratios are equal, you have successfully proven similarity. At this point, you can formally state your conclusion, writing that the first triangle is similar to the second triangle by the SSS Similarity Criterion. In the next slide, we are going to see this exact process applied to a real-world architectural example to see it all in action. 3. Real-world example, architectural scaling. Now that we have understood the theory and the logical steps behind the SSS criterion, let's see how this applies to a real-world situation. Imagine an architect is working on a new project. Before building a massive house, they create a small, triangular scale model of a roof section to visualize the design. In our scenario, let's look at the measurements. The small model triangle has side lengths of 6 centimeters, 8 centimeters, and 10 centimeters. The actual full-sized roof triangle is much larger, with sides measuring 1.8 meters, 2.4 meters, and 3 meters. To determine if these two triangles are truly similar, we need to perform a step-by-step verification. First, we must address a crucial detail. Step 1 is to convert our units so they are consistent. As I'll mention later in our common mistakes slide, you can't compare centimeters directly to meters. So, let's convert the actual roof measurements from meters into centimeters. 1.8 meters becomes 180 centimeters, 2.4 meters becomes 240 centimeters, and 3 meters becomes 300 centimeters. Next, in step 2, we pair the corresponding sides. Following the rule we learned in the previous slide, we pair the shortest with the shortest, the medium with the medium, and the longest with the longest. So, we pair 6 centimeters with 180 centimeters, 8 centimeters with 240 centimeters, and 10 centimeters with 300 centimeters. Now, for step 3, we calculate and compare the ratios. Let's do the math. The first ratio, 6 divided by 180, simplifies to 1/30. The second ratio, 8 divided by 240, also simplifies to 1/30. And finally, the third ratio, 10 divided by 300, also results in 1/30. Finally, in step 4, we reach our conclusion. Since 6/180 equals 8/240, which equals 10/300, all of which equal 1/30, we can see that the sides are perfectly proportional. Therefore, we can formally state that the model roof is similar to the actual roof by the SSS Similarity Criterion. This confirms the architect's scale model is an accurate representation of the final structure. 4. Common mistakes to avoid. First, please be careful not to confuse similarity with congruency. This is a very common error. You might find yourself thinking that the sides must be exactly equal, for example, saying that side AB equals side D, but remember what we discussed in our second slide. For similarity, we aren't looking for equal lengths, we are looking for a constant ratio. The sides don't have to be the same size, they just need to scale proportionally. Second, watch out for the incorrect pairing of sides. When you are looking at a diagram, it is tempting to just pair the sides based on where they are positioned in the drawing. However, don't let the visual layout trick you. To be mathematically accurate, you should always pair the shortest side of the first triangle with the shortest side of the second, the medium with the medium, and the longest with the longest. This ensures your ratios are actually comparing corresponding parts. Finally, never ignore your units. As we saw in our architectural example with the roof model, comparing 6 centimeters to 1.8 meters without converting them first will give you a completely incorrect ratio. Always, and I mean always, ensure that your units are identical, whether that is all centimeters or all meters, before you start calculating your fractions. Now, before we wrap up our lesson, I want to pause and discuss some common pitfalls. Even if you understand the theory, it is very easy to make small errors that lead to the wrong conclusion. Let's look at 3 specific mistakes to avoid. Keep these 3 points in mind, and you will be well on your way to mastering the SSS criterion. Now, let's move to our final slide to summarize everything we have learned today. 5 key takeaways. First, remember the core definition of the SSS criterion. 2 triangles are considered similar if their corresponding sides are in the same proportion. This means they aren't the same size, but they have the exact same shape. Second, it is important to understand the implication of this rule. As we discussed in our earlier slides, once you have successfully proven that the sides are proportional using the SSS method, it is mathematically guaranteed that all of their corresponding angles are also equal. You don't need to measure the angles separately. The side ratios do the work for you. Third, let's look at the mathematical condition one more time to ensure you can write it out correctly in your proofs. We say that triangle ABC is similar to triangle DEF if the ratio of AB over DE equals the ratio of BC over EF, which also equals the ratio of AC over DF. Finally, I want to leave you with one last reminder to avoid the common mistake we touched on earlier. Do not confuse similarity with congruency. In SSS congruency, we require the sides to be exactly equal in length. However, in SSS similarity, we only require the sides to be proportional. All right, we have reached the end of our lesson, so let's take a moment to recap the key takeaways from today's session on the SSS Similarity Criterion. I hope this summary helps solidify your understanding. Keep practicing those ratios, and I will see you in the next lesson.